we're kicking off Unit 2 with PO7, a PO to start out Unit 2. In fact, Unit 2 has quite a number of POs in it. If we look back way at the top where we get our table of contents, way up here. Unit 2, oh, it only has 3 of them. I thought it had more than that. Anyway, 3 right off the bat. And so this is going to be one. It goes pretty quickly because you've done all of these before, except for estimating the value of a square root. So it goes pretty quick. We'll have a test probably by Halloween. I'm not going to go that. I'm going to go faster. But we do start out with 3 POs. So comparing and ordering decimals, fractions, and integers. Let's start with kind of looking at these 3 symbols. These are the 3 symbols that you're going to be using. What does this first one mean here? The first one in that table. Yeah. It is the less than. Ziki, what is your strat for remembering that that is the less than symbol? Strat that.
I really don't know. I just guessed.
Oh, you're right. Jillian, what's your strat for remembering that's the less than symbol?
For the greater than, the little alligator.
Yes.
Right.
No.
Yeah, which is true for this symbol too, right? If you actually have a statement, if you have 8 is less than 10, that gator is still eating the larger value, right? So it works for this also. Anybody have a different method other than the gator?
No.
Yeah.
Or just like the tip of the arrow thing. Yeah.
Okay, so the it's kind of like an arrow. It's pointing to the smaller value. That is true for the second one also. If we have 10 is greater than 8, not only is it eating the 10, but pointing to the 8. Any others?
There's a song about the great man.
Can you sing it for us?
Yes.
Oh.
We did it in first grade.
Oh.
Yes, Julian, you got it.
Well, how I always remembered it growing up was the less than symbol. If you take the L in less than and kind of turn it and squish it down a little bit, it makes kind of that symbol there. Okay. Whatever works for you, that's what's important. But you need to know, obviously, which symbol means which thing. Otherwise, you're not going to know which symbol to put down. Okay. So this is greater than. We have less than, greater than, and of course, you know the third symbol. It is equal to, or the same as. Okay. The equal symbol, Ziki, doesn't just mean the answer. It literally means the same as. Okay. Questions on those symbols? Review, correct? Yes. Okay. Let's talk about integers. Integers, you can compare them using a number line. If you picture a number line in your head, the further to the right on the number line, the greater the value is, right? Likewise, the further to the left on the number line, the lesser or the smaller the value is. So if you think about -7 and -10, if you want to plot this, just put 0 wherever you want, and then where would -7 be? -7 would be to the left of it. You don't have to write out every number along the way, unless you need to, okay? And then would -10 be on the right side of -7 or the left side of -7? The left side. Okay, because as you get further away from 0, just like on the positive side, you get to 7 before you get to 10. On the negative side, you get to -7 before you get to -10. So as far as their values, because -7 is further to the right, what symbol is going to go on the line then? Is -7 greater than or less than -10? Greater. Okay, it is further to the right. You can think about it in terms of temperature. -7 is warmer than -10. Not by much, but still. Okay. -4 and +2. What symbol is going to go in there? Negative compared to a positive. It's always, Gigi, less than. A negative will always be less than a positive. -2 and -9. Gigi. Greater than. Similar to -7 and -10, -2 is further to the right. Okay? As you start going from 0 to the left, you hit -2 before you get to -9, right? -2 is on the right side of -9. There it is, greater. Lastly, for what we'll do together, -14 and -12. What symbol's going to go there? Liv. Oh, where's your hand up? Sorry. Yeah.
This.
Well, what is that?
Greater than or less than.
Less than. Yep. -14 is further to the left. It is colder than -12. Therefore, it is less than -12. Okay. Yeah.
Would 8 something -8, would that be equal because they're both the same distance from 0? Or
Is 8 degrees the same as -8 degrees?
is -8? No.
It is not, right? They are opposites in the sense that they're the same distance from 0, but they are not equivalent or equal values. So for tomorrow, you need to finish the rest of this section on integers, including the where you've got 5 or 6 of them to list in order from least to greatest. Okay, the smallest value is first, least to greatest. Gigi. If I can speed run a Mario level, I can speed run the rest of PO7, Gigi. Believe in me. Here we go. Okay. Comparing decimals. What's your strat for comparing decimals? Again, this is review. This is actually on your Unit 1 test as a review of last year from Math 6. So I kind of, here's a lit connection. I foreshadowed PO7, right? What's your strat for comparing decimals? Bennett.
I look at the first number after the decimal, and if it's like bigger than the other one, then it goes full second one.
Sure. So 0.223 and 0.793. Bennett's saying she's looking at that first digit, the tenths place, and it doesn't matter what comes after that, right? 7/10 is greater than 2/10. Therefore, 793 is greater than 0.223, or the way it's ordered, 0.223 is less than 0.793. Okay. Anybody else? Zeke, you had your hand up too. What strat do you have? Same thing. Okay. The next one, 67.4 and 63.22. What symbol's going to go in between those numbers? 67.4, 63.22. Amelia. Greater than. Even though our tenths digit, 4, is greater than 2, what does that rule not apply for this? Or what do you really need to look at first before you move to the tenths? Gigi. The number of holes, right? 67 holes is greater than 63 holes. Okay? So the value is greater than. 2.54 and 2.5400. Nora. Equal to. You can add zeros to the end of a decimal all your life and not change the value of it. Because all you're really saying is that this has 2 holes, just like the first one, 5/10, just like the first one, 4 hundredths, just like the first one, no thousands, no 10,000s, etc., just like the first one, right? Those zeros just tell you there's no value in that place. Whether you write the zeros or not, it means the same thing. Okay? The values stop at 400. How about the next one? 0.27 and 0.3. What symbol goes there? Ziki.
Less than.
Why?
Wait. Less than because the 3 is in the right spot.
Tenths. Yeah. And 3/10 is greater than 2/10. But isn't 27 bigger than 3? Yeah. So
Oh.
no, trust your gut, Ziki. Trust your gut. Okay. Even though 27 is bigger than 3, why is 0.27 still less than 0.3?
Because it's bigger than 2.
You look at the tenths place, right? There's something called the stacking method that maybe you've seen before. If you were to stack these decimals vertically, 0.27 and 0.3, notice how the 0.27 is out to the hundredths place? And what can we add to the end of that 0.3 to put that one out to the hundredths place as well?
0.
A 0. And now you see, oh yeah, 27 is less than 30, right? a lot of times, and this didn't happen for some of you on the test, for those whom it did, you get to learn about it now. You can't just look at the 27 and the 3. Because it's not 27 and 3. It's 27 hundredths and 3 tenths, which is the same as 30 hundredths. So if you look at 27 and 30, now you can compare them because they're up in the same number of places. Okay, so watch out for that. That happens a couple other times throughout this page as well. So finish decimals, the 4 that we didn't do, and then that section down there, again, least to greatest. Highly recommend the stacking method for this. Highly recommend the stacking method for this. And then lastly, everyone's favorite thing, fractions. How can you strat fractions? 3/6 and 5/10.
I know.
What symbol would you put in there? Aiden? Equal. I'm very curious to hear your rationale for this, considering 3 and 6 and 5 and 10 are totally different values. Like they're not even the same numbers.
Well, they're both half of their numbers.
How do you know they're both equal to half?
Well, because 6 divided by 2 is 3, and 10 divided by 2 is 4.
Okay, so if you were to simplify each of these fractions, what would you get? What is 3/6 in simplest form? You already told me half, right? 1 over 2. If you simplify 3/6 and you simplify 5/10, you'll see they are both equal to 1/2. The way Aiden described it is perfect as well. He's saying, well, 6 divided by 3 is 2, and 5 divided by 10 is 2, or 3 is half of 6, 5 is half of 10. With fractions, your numbers are going to be different, but you're looking at the values. Right? What is the value of 3/6? Getting 3 out of 6 on a test is really the same as getting 5 out of 10. You got 50% or half on each of them. And so they're equal. Okay? How about 3/8 and 7/12? This one's a little bit trickier. Who's got a strat for this one? First, who has an answer? And then, can you strat that? I'm trying to copyright that. Strat that. Anybody bold, brave? Bennett?
Is that, wait, so 3/8 is bigger than 7/12?
Why?
Because that would be, like if you did a circle and like cut it into shapes, is what I would do.
Yep.
And then that would be more of the shapes are filled, or like more of the circles filled.
Okay. So Bennett's going with the pie chart deal. It can be kind of hard to cut a circle into 12 pieces or 33 pieces. So if the circle is not for you, you can make a candy bar. Just make a rectangle, right? And so if we make a rectangle here, and we divide this into 8 sections, which I'm going to do first by dividing in half, then divide each half into half. Now I've got fourths, and then divide each fourth in half, and now I have 8 pretty equivalent sections, right? I color in 3 of them, and here is 3/8. Okay? For 7/12, I'm going to do the same thing. Make sure your bar is the same size, right?
Wait, I'm wrong.
Oh, you're going to change your answer?
Yeah,
Okay. How'd you know you were wrong? I haven't even made the candy bar yet.
because it would be opposite. Like 7/12 would be more.
Okay.
Wait, I don't know.
Well, let's just test. So I've divided this into 12 pieces. So I'm going to put in a half first, right? And now I essentially have to divide each of these halves into sixths. So I'm going to divide this into half again, and then into thirds, right? So I got 6 pieces on the left there. Same thing here. First divide half, and then thirds, and now I have 12 mostly equally sized pieces. If I shade in 7 of them, 1, 2, 3, 4, 5, 6, 7. 7/12 is greater than 3/8.
Technically, I was right.
Well, yeah, if you say both answers, you're going to be right. Good job. Okay. Jillian, how did you strat that?
I did 8 times 3,
Hmm.
and then 9/24, and then 12 times 2.
Ooh, a little least common multiple going on there. Yeah, get common denominators. If we use equivalent fractions, multiply 8 by 3 and 3 by 3, we get 9/24.
And then
If we do the same thing with the 7 and the 12, 7 times 2, 12 times 2, 14/24. Well, 14 out of 24 is greater than 9 out of 24. Okay? Anyone else have a strat for that? What if we compared to half? Like, think about 3/8. How do you know that's less than half?
because 4.
Because 4/8 would be half and 3 is less than 4, right? How about 7/12?
It's greater.
How do you know it's greater than half?
Because 6/12.
Because 6 would be equal to half and you've got more than that. So if you've got something that's less than half versus something that's greater than half, obviously it's going to be less than. So we have 3 different strats for this. Equivalent common denominators, kind of comparing to 1/2 is using logic, or making the candy bars that you can do for this. Your homework for tomorrow is not going to be fractions. I feel like fractions could use a little bit of work yet. So just the integers and decimals for tomorrow. Okay, just integers and decimals for tomorrow. By the way, be kind, be brave, believe,
I feel like this is direct, yeah.
be nice.
Be a woman.
Love it.
Can I
Okay.
not do like the.
All right, questions, comments, concerns, complaints, comments, congratulations, criticisms on this. Yes, Matthew.
Congratulations on the topic. Thanks.
Thank you very much.
Well,
All right, homework for tomorrow. Integers and decimals only. That's it, Matt.
Don't forget to like and subscribe.